All right. You did. Thank you for the invitation. So also thank you for presenting me. I guess we can start with our subject, right? I'll share my screen and feel free to ask any questions. The presentation will be brief. We'll focus more on answering questions if there are, or the talk about the technology in itself. The slides are just for helping us with the subject. So everybody have used ChatGPT, I think that. And the ChatGPT is a large language model, and these large language models are helping us. Usually we use them on the platforms, and it's not made for production. So if you are working with a company and you want to harness LLMs for your projects, you need more mature tools to use. And for that, I'm proposing for this talk, Azure RAG architectures. And during this presentation, we'll deep dive into what RAG is and how we can implement it using Microsoft Azure. We're gonna propose few things. First of all, an introduction. Then we're gonna jump into advanced RAG. After that, the multi-model. If you are familiar with the AI concept, you will know what multi-model is. If you are not, we can explain it. And the last technological point, which is the newest one, is agentic AI. And we're gonna use it in RAG. So don't be discouraged by the jargon, it's fairly easy. And we're gonna give some real life examples. For the workshop, I don't think we'll have time for that. Also, I'm giving these lectures in Tunisian universities we'll play with Kahoot. I don't think that would be suitable for YouTube live stream. So, in introduction, what is RAG? Usually when you are on the OpenAI platform, you will have a question. Except if you own a business, you will have too many questions or too many documents. And what you need to do is feed them into your model. Now, why I'm advocating for using cloud services is because it's much easier than building it in-house with open source tools. It is free, but it's not sustainable, it's not scalable. You need to make some investments, cloud investments. But if you want to do it on-prem, please be my guest. It will be an exciting project to do and a lot of troubleshooting. So if you want to go to the market fairly quickly and take advantage and have an edge, it's better to use already mature services. So let's assume you are trading, you are working with a bank, or you are working with a financial institution. I think everybody knows what trading is. And you have Apple stocks, and you have thousands of pages of financial research and analysis. And you have an analyst who's always busy, working 12 hours a day. How can you help them? How can you speed up this process? So you will try at first to chunk your model, divide your model. And if you have an NLP background, you will know that it's not a new concept. After that, you will embed your model, and embedding, you will use a large language model. But its use is to vectorize your data. This is a data science community, so I'm assuming these technical words you are familiar with. If you are not, just raise your hand. So after embedding the data, we're going to put it in a special database. It's called vector database. And it's different from SQL. It's different from MariaDB, PostgreSQL. It's a database dedicated for searching vectorized data. And that's what we need to interact with an LLM at a large scale. What we also need is the question. So you will be asking, is Apple stock going up or down tomorrow or after a month or after 10 years? That would be your query. Your query needs to be embedded too. So you type it in plain English, and then it's going to be vectorized. And that query vector can be searched using semantic search, vector search inside your vector database. What we're going to add is the context. So we have a document that has been embedded and vectorized and stored in a vector database. We have a query that has been embedded and vectorized, ready for semantic search or vector search, or both at the same time. Plus that, we have the context. The context can be, hey, I'm working in a hedge fund, and I need the best analysis on Apple stock and its correlation with Microsoft stock, and blah, blah, blah. That would be your context. So you put your query in special setting. Also, context can be an example. Like, give me these bullet points one by one, and you are structuring the response in a certain way. Now, combining a query and a context, we will formulate a prompt. And that prompt template is the way you're going to interact with your large language model. This large language model can be DeepSeek, can be Claude, can be Gemini, whatever floats your boat. The last step is to generate the response. So what we have talked about at the first stage is ingestion, how we ingested the data, and what delivered the response is called inference. And like I said, this is a data science community, so I will not be explaining in detail what inference is, but basically it's the process of you already trained the model, now you're going to apply it on a new data, and that new data will be your query. We can divide RAG into 3 steps. I cannot seem to, okay, good. Or maybe like this, yeah. So we divide RAG into 3 stuff, like 3 different phases. It's retrieval, then augmentation, and then generation. All these 3 will give me a RAG concept. For me, I was not surprised to see this architecture because that's what we do in NLP. But these steps are more tailored for using large language models. Because an NLP cannot augment the data really well, and it can retrieve, but it's limited. It can generate, but it's also limited. So the next step for NLP is the LLM, is where you are not limited in retrieval, you are not limited in augmentation, and you can generate something human-like through combining retrieval and augmentation. So for a data scientist, you should know NLP, you should know how it works. This is like the next level of it. These are the steps that I already explained, and now we're gonna deep dive into advanced RAG. And in here, why there is no medium level is because the concepts are fairly simple. The architecture of an advanced RAG lies into the pre-retrieval stage and the post-retrieval stage. You need, if you have a vanilla use case, then you just do the basic stuff. But sometimes, for example, if you're working with documents that have data that can be distorted through chunking, then you need to be super careful about the way you chunk your data. You need to be careful about how you embed your data, and the embedding can include computer vision, specifically OCR, optical character recognition. And we are not here only talking about text, we're talking about images. We can embed them. You can also convert audio to text and then embed it. You can convert audio into images, and you can convert video into images and embed them. And the audio of the video, you can convert it into text and embed it. So it can work with complex scenarios. Of course, plus added costs and complexities to stitch everything together. Everything will be stored in a vector database, and it will make a coherent context. So if you watch a YouTube video, from a video you can extract images and you can extract audio, and from images and audio you can extract text and put it in a vector database. So we interface through these concepts, through these tools. The way we interface, at least on Microsoft Azure Cloud, and in here I'm not making any advertising for them, but they happen to be to have a good working services. These services let you interface with these concepts fairly easy, but if you want to have something customized, you need to code it. They offer low-code solutions, but they are limited. So they offer coding solutions where you can, in here interfacing will be different because you need to write your own code. The added value between that and something on-prem, something open source, is that they give you the essential source code to make things happen. If you work on open source stuff, you will be Googling what I can do, from where I'm going to get my code. At least for Microsoft Azure, they in their documentation, they always give you the essence of the code, and then you develop from that. Now, in the post retrieval, they have something like prompt flow, and you can put multiple contexts in there, and you stitch them together to have a prompt template that is complex and advanced. So, for example, if you are trading semiconductors, you are trading a cluster of tech companies, financial companies, then you will need templates specific to that. So the context will change from semiconductor market to tech market. It can also change from one financial market to another. For example, Japan and the US. How can we control that? Through prompt engineering. And it's a very glorified word. And now we hear about prompt engineers. They are fake engineers. And the concept is easy. You will do some if else, and your ifs will have conditions based on your business understanding. So if you are trading in Japan, you will tell it contextualize what are the specific things to the I believe it's Nikkei stock market. If you are trading in the US, you will tailor something to NASDAQ or Wall Street. And you can put that in your prompt template. Now, the more advanced scenario is to use multiple LLMs, and every LLM will be doing something different. And that will be our last talking point, which is agentic AI. But if you get but you should get the idea from here that this is the basic stuff that you can develop it and leverage it for advanced scenarios. So ideally, I wouldn't be calling this advanced, I would call it medium, and the advanced version is agentic AI. Now, why I'm adhering by this, because I'm getting my content from Weaviate, is a Dutch company. They have their logo on the vector database, and I think they have the most mature explanations of stuff, so I use their materials. Kudos to them. Now, these are more technical stuff that I covered broadly. And one of the stuff that you should know, the way you search data also can be a bit different. You can do like a vector search, semantic search, a hybrid search. Depends on what information you want to extract and the data type that you are dealing with. And here it's a comparison between what vector search can do and what similarity search can do. These concepts are old concepts, so we just leveraging them with new technology. So, what is a multi-model RAG in Azure? A multi-model RAG in Azure is what I was already explaining. Let's assume that your data is not PDFs and it's not text. And in here, if you go to ChatGPT, I'm only sharing a tab. Yeah, so we'll just leave it to this tab then. And if you go to OpenAI and tap a query, type a question, that question is a text. How about I want a video? Then we are talking about the context of multimodal. And the video, I want to add to it some audio and I want to add to it some text. So I need a model for each. And here comes the concept of multimodal setting. If you're gonna build everything from scratch using open source and on-premises resources, that will take you forever. The easy thing is to use Azure AI Vision for images. So you can segment your video into images and convert the content of images into coherent text. You can do that for audio. And then you give it to ChatGPT-4, you can give it to Grok AI, you can give it to whatever you want. After that, the app will be consumed through Azure App Service, and it can be a website, it can be a mobile app, and the entire pipeline can be orchestrated using Azure Functions. Or, for example, I prefer Django. Django is a backend, Python backend for web applications. And you can define your preferred stack in here. One of the most essential components, it's an old component, is the Azure AI Search. The Azure AI Search can browse documents. It's an old service, but now it can browse, can be used with LLMs. I think it's the most tricky one to learn, but it's not difficult. And it combines most of your resources. It combines Azure OpenAI for embedding, for interacting with the LLM. It combines your access to the storage when you put your data, your AI vision, because it have an embedded, in the embedding, you can use AI vision. There is plethora of added functionalities to it. So if you learn AI search, you'll probably end up learning most of what Microsoft Azure is offering. Now, I'm remembering, before moving to agentic RAG, I'm remembering something. In the beginning of this talk, you said we're going to deviate from data science. This is actually data science heavy, because the data scientists, they need to know software engineering, they need to know AI, they need to know cloud. And if you don't know these three, you cannot be a good scientist, data scientist. Also, just for fairness, I don't even like the word data scientist, even though my contract now says I'm a data scientist. We are software engineers with multiple skills, and we are good at analyzing stuff. The rest of things are just tools to facilitate what we are doing. So today is RAG, tomorrow is agentic AI, yesterday is backend dev. In few months or years, we'll be relying too much on DevOps. So I don't think this is science. I think it's what software engineers need to know. And in the future, software engineers, all of them, will be using AI and building AI. So as a data science community, I think you need to be well versed in cloud services. Now, the most exciting point is agentic RAG. And I hinted on how to use agentic RAG. So basically, the first architecture, we're going to multiply it by at least 2. So I will have a master LLM interacting with slaves LLM. And the slaves LLM will have a niche skill, and they will communicate with their master, and their master will decide what to do with the expertise of the slave LLM. So an LLM with expertise in something specific is called agent. And in less than 1 year, we moved from RAG to agentic RAG. And now we are talking about agentic softwares. Is the new breed of softwares when you do not explicitly code everything for your software to work. So your software will have some degree of liberty to navigate their business use case. So the software will become a live tool. We are used to tools that can deliver what we specifically tell them, and we specifically programmatically put into them. Agentic softwares have more degree of thinking, so their action can be considered as intelligent. Multiple agentic RAGs, you can build your own army. So let's say you are trading meme coins or altcoins or shitcoins. I think the three stands for the same thing. You cannot be expert on all of them, but you can dedicate special agent for each. And then your master agent will collaborate with them and decide which alternative coin you want to buy. That will give you edge over someone who's doing all things by themselves. You can also use agentic RAG to take control of over your laptop and do tasks. So data scientists love scraping, which is a technique of data collection. You can tell your agents to scrap the internet for you. And then you will have agents to analyze the data that have been scraped. And this is the future. Normal softwares, they cannot do that. They need to be programmatically and explicitly delivered with every step of the way. With AI agent, we are introducing a degree of autonomy and intelligence to them. And with a master agent, it will control what the outputs can be. So that's what agentic RAG is. And you can deploy it using, you can build it and deploy it using open source, on-prem capabilities, or you do it on the cloud, on your preferred cloud. So I will show you an example of Microsoft Azure architecture, and this is for building a recommendation engine. We're going to start on the left with number one. So you have data coming from a blob store, and you have data coming from Cosmos DB, S2, Azure storage services, and then they will go through a GPT model, and you expose them through a model endpoint. The strength of cloud services is the ability of those to use off-the-shelf service and have an endpoint for it. If you do it and code it from scratch, that will take days. The easiest scenarios will take hours, but if you consume it directly from a cloud provider, they will directly give you an endpoint for it to be consumed. So you don't build the endpoint, you don't build the service, you consume the service and use the endpoint, which is, I'm talking about this. You can see my lovely pink green cursor. My cursor is very woke. Donald Trump does not love these colors. So after that, we're gonna have the model sending the data to Chroma, and it's a vector database that we talked about before. And we're gonna orchestrate the whole. So the Chroma will send the data to the recommendation, and you can build your recommendation engine with whatever you want. You can use scikit-learn on Python. You can use Keras and TensorFlow. And then we're gonna have rankings. That's what recommendation engines do. And the output of it is gonna be communicated to Azure Function. Azure Function in here is a way to orchestrate all your services. They're gonna communicate with, they wanna uh, communicate with Azure Cache for Redis is a third type of storage to cache the results. For your endpoints, you're going to have an Azure API manager. So if you are building your APIs like me using Django REST framework, it's a bit of a hassle. And then to manage all your APIs, it's even more work. What you can do is use Azure API Manager. And in here, I'm talking about both of my professional experiences. I don't only just use Microsoft Azure, but I also use free tools like Django, Django REST Framework, VS Code on-prem, and I rely on the cloud when needed. After that, the user will use the recommendations. And like I said, you can use it to buy altcoins, you can use it to buy Apple stocks. I actually don't recommend that. Don't do that. You will lose your money. But it's just an educational example. Please don't do it for trading. LLMs are not meant for numerical data. These are just academic, purely academic examples. That is easy to understand. But I'm sure your professors at the university will think this is a brilliant idea because they have no life practical experience. With all due my respect, I'm seeing them proposing subjects and doing research is a complete waste of time. You use YouTube wisely. And we're gonna skip these parts and see if you guys have questions for me.
No, no, I mean some noise. No, nothing to say. Sorry, just when the Mouafek talks, we can hear some noise. That's always fine. Yeah, I enjoyed the session. It's very important. Thank you, Mouafek, to accepting our invitation.
Yeah, my pleasure. First time doing something with the Moroccans. So that was my first reason to accept. Let's do something with the Moroccans.
Yeah, yeah.
Yes. Oh, I'm seeing. So I've been involved with people doing research, like PhD students, and their professors who try to help them with their subjects. And I'm also involved with regular students doing their regular courses at the university. And I worry when I hear these professors talk. And I worry what the universities are doing. They are completely detached from reality. And I'm afraid that their recommendations for the youth is misleading. Because this is the biggest flop of the data science community in the world. They focus on analysis and they forget about software engineering capabilities. So in Tunis, we have thousands of data scientist students and they cannot get a job. So when I tell them, hey, please go learn software engineering, they will be like, why are we going to do that? I'm a data scientist. No, you are not. You are a software engineer with analytical skills. So please learn software engineering and then leverage your analytical skills. And what the professors and universities are guilty of is to point thousands and thousands and thousands of students into the wrong direction. It's like learn machine learning and do a PhD thesis on this boring subject that the market does not care about. And these poor students, they will lose at least 3 years in a PhD that does not give any value to anyone. Also, if you are an engineer and you graduated in engineering school or you have a master's degree, I know in some countries they only have masters in engineering. In Tunis, they are separate. Also, you will be losing your time because if you know how to do machine learning and you don't know how to build the software, your skills is going to be not very appreciated in the job market. And when we are talking about the job market, we are talking about building real life products. So in order to build a real life product, you should know cloud, you should know DevOps, you should know backend development, you should know how to build your own APIs, you should know how to communicate properly with the business, with your teammates. Machine learning is just 10%, if not less. And I will argue that most of the time, machine learning is less than 10% in any job, unless you are doing AI research. And please be careful about whatever AI research are you going into. It should not be outdated. So what I'm seeing is most PhD theses are obsolete. They will be telling me about their great ideas. It's not great. You should know what the state of technology today is, and then invest wisely into what you're gonna do. Do not lose your time. Check what is the trendiest thing on YouTube. Ask the companies what, like, for me, I'm here with you. You can ask me what companies are looking for. I have LinkedIn messages. People ask me, what are you guys doing? If you tell a university professor reading from a PDF for 20 years because he had a PhD in math 20 years ago, what should I do? He will give you something probably not aligned with the market needs. And as a data scientist, you should analyze this situation very carefully. So if you are a good data scientist, you will analyze the market really well. You will analyze your technical skills really well, and then decide what's going to be the best path for your career. If you learn machine learning and you think you will get the job, if you get the job, you just got lucky. You got to be well versed in software engineering. If you want to do research and be in some advanced AI creation, you should know a lot of math, which data scientists skip. Personally, I don't really like math. But when I need to learn what gradient descent is and I have a Keras model working, then I'm going to learn it. But that's less than 10%. Like I said, the exception if you are doing AI research. And it should be a novel one that a company can use it. You can build the product with it. Don't do the hypothetical stuff. Professors do not know the market. They talk about hypotheses that does not work in real life. So please ask people on LinkedIn, check YouTube, check the news. Don't gamble your career, especially if you are below 30 years old. You can skip the first things I've said, like the first 13 minutes, and focus on this. It will be more useful to you. Maybe a few years back when I started, they actually needed somebody who learned machine learning. But now you can just call an API. Well, why will you waste your time? The job market is changing, and you can see the decline in the demand for IT skills. So if you are smart, you will analyze the situation and decide to know multiple software engineering skills and try to leverage them. And the fact that you guys on a Wednesday night at 7 p.m. are present, that speaks volume because most people won't be present, but you are. So you probably analyze the situation pretty well. Let's get some real knowledge, not from a university professor reading from a PDF that you can read by yourself or feed it into ChatGPT and end up with a better explanation. I'm not attacking them because, by the way, I teach in universities too. So they are my colleagues. In real life, when you get a better salary, it's not perfect. There is a lot of challenges. So at least for people below 30 years old, I think they should be aware of this. Your professors are not idle, and so does your corporate managers. Nobody is your idol. Your idol is your knowledge and how much you can invest in your personal skills. And I think this is what lacks software engineers in general, is to actually have a sober conversation about where the market is heading toward. And if you ask companies, be careful about the people that you ask, because if I'm talking about the academia flops, the profit sector have their own flops, but that's a discussion for another time. Yeah, yeah, yeah. I think the Moroccan market is a little bit better than the Tunisian market, even the salaries. I know that, and I think it's a big mistake to go from grad to PhD. You gotta need some real life experience, and if you have a sober conversation, what kind of a subject they will give you in PhD that the market did not already solve? Do you have clusters of NVIDIA GPUs to invent something new, or your professor or university? With all due my respect, I know that there are top Moroccan universities, but unless you are in a big university that can invest a lot of money into your research and sell it to a company, then they will have zero added value for you, unless the only exception is your objective is to be a teacher and read from a PDF until the rest of your life about outdated subjects that benefit absolutely nobody. Yeah, and you can do them on the same time. I know people who write a PhD thesis while working with a company, so you will have double income. Income, yeah, sure. Oh, that's the best. That's the best. Do that. Yeah, because you are building something toward real life, so you can use. It's like building a phone. I can give you my phone. You can use my phone. Why you will build me something that nobody cares about and nobody uses? And it sits in university, and the professor put their name on, and nobody benefit from that. Why you will waste 3 years? If it's a time series problem, you will use ANOVA, ARIMA, SARIMAX, and you will analyze it, and you will know it's completely useless for you. Imagine it like that. But if you're gonna use ANOVA and ARIMA, for example, for stock trading, that would be beneficial for you. Always use analogies, and um, that will help you. Try to dumb down every situation. Like, take a step back and be objective. Unless you want to be a professor in a university. That's a much difficult path. You will get paid less. You will talk to dinosaurs. And I'm not attacking them because I used to teach. I still sometimes teach. I will be teaching next week. And that does not make that the corporate profit for profit organizations are good. No, they are filled with flops. But for me, I'm 31 years old and I'm seeing a lot of wasted potential. So if I see somebody who's below 30 years old making a bad life decision, it makes me sad. If you are plus 30 years old and making bad life decision, you probably need to have a severe assistance. Yeah, and you need to also think about the fact that you can paste any document in ChatGPT and he can teach you the skill. So you will ask yourself, why will I be doing this if anybody can be taught by GPT?
Uh, yes, yes, Qatar. We have some questions in chat.
On-prem. So that's a brilliant question. I'll start with LangChain is the best. And with LangChain, I will use Chroma DB as a vector search. I will use as an open source DeepSeek, for example. I will use Docker to containerize my model. I'll use Django for API endpoints and web application if you want a web application, but I don't have a favorite stack. My favorite stack is the one that can make me money. That's my favorite stack everywhere. And Azure makes me money. And that's why it's my favorite. So, guys, be ruthlessly ambitious and follow. I wouldn't say follow the money, follow the knowledge, and with knowledge you end up with money. And that's, I think, we are doing this for profit after all. What do you think about some open projects like Ragflow, OpenWeb UI? I think they will soon disappear because big companies are like, for example, if you take OpenAI, every open source idea they are building something closed source for it, and it's usually better. So Ragflow is good. I wouldn't say they are not good. They are actually good. It's just at some point, for-profit solutions which are not open source outpace the open source. And there are open sources that you pay for a wrap around them, a more mature wrap, they can be good too. So it's like hybrid. On the low level, it's open source, but you interface with the open source with the paid solution. I think that's ideal, and it's usually less expensive than cloud services. No, 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 no. Like I've been doing this since 2020, and sometimes we end up with 5 people, and it's perfectly fine because I like doing this, and I wish people have helped me in my software engineering career. And most of the time, I didn't find help. So when I see people who are at least younger than me trying to get some insights, I just try to help. I don't judge numbers. I know you do it in the weekend, you do it 8 p.m. Unfortunately, I cannot do that, even though at the first interaction I told you I can, but it turned out to be impossible. But I truly appreciate it. And like I said, it's very lovely and heartwarming to interact with Moroccans. I had really good friends in Holland and Amsterdam from Morocco. So it's really great to see you guys. Yeah, so why Chroma over Fast? Chroma was recommended to me by an intern. So I have 2 interns. They said Chroma is better. So I was like, do you know what, guys? Let's do Chroma. I do not have objective metrics or insights. I have 22 years old, 23 years old intern, and another one, 27. It's like your age bracket, guys. So they said that's good, so we tried to work with it. But then we switched it to cloud, of course, and eventually in production we did not use it. But most positive reviews, I'm seeing them on Chrome. I do not have objective metrics to compare. Thank you for the invite. Hopefully to see you all in real life.
Thank you, Mouafek.
Thank you. Goodbye.
Culture. Can you talk about next step, about MDS, about the conference, etc.? Thank you. Thank you, everyone. See you next episode.